take each statement in turn and try to represent them on a number line. Okay, so first up, I'm going to go with the simplest ones. We've got 0 is less than x, which is less than 1. It's going to look like this on my number line. I'm not including 0 or 1. And -1 less than x less than 0 takes us to here. Actually, I'm just going to raise it slightly above. Okay, so there's no overlap, so those two couldn't be true at the same time. Okay, onto some tricky ones. If x squared is between 0 and 1, then we can just sort of think about this. It must be that x itself is less than 1, because as soon as we get to 1 or more, then x squared will be 1 or more as well. But we can also look at the negative side of things. Minus 0.9, for example, if we square it, gives 0.81, so that would still work. So this is true, except we can't have x equal to 0. But x equal to minus 0.1 or x equals 0.1, that would be okay as well. So if I show that in green, I'm going to get this. Technically, I'm going to have a missing part here and here. Okay, so I can definitely have two correct at the same time, because I could go with, say, 0.5, and then the green and the blue statements would be correct. By the way, I can't have x equal to 0, like it's not included in any of these sets. Okay, so get rid of that one. All right, what about x squared greater than 1? Well, this is actually the reverse. Either x is going to be greater than 1, or x is going to be less than -1. It's the reverse of the green one. So now I'll be going this way, or this way. Okay, so that doesn't help a great deal, actually. Although it does allow me to rule out 5, and I think I've already ruled out 4. Okay, so it comes down to this last statement here. Well, what we can do is factorize x minus x squared, giving x1 minus x. Then I'm going to consider a little sketch of y equals x times 1 minus x. This will have roots at 0. Forget the fact that it has to be greater than 0, less than 1. I'm just drawing the graph at the moment. And a root at 1. And then it's a negative quadratic. So it's actually going to come up and down like this. The maximum point is going to be at a half, because it's a midpoint of the roots. And when x is equal to a half, we do a half minus a half squared. That's a quarter, giving us a quarter. So we're interested where this function is between 0 and 1. And it's actually going to be, therefore, x is going to be between 0 and 1. Because between these values, the function is between 0 and a quarter. So it's definitely between 0 and 1. Okay, and that's the key to this. So we can add it in here. And we can see, for example, if x was 0.5, then all three of these would be satisfied. That is the largest number that can be satisfied at the same time, therefore 3.